So I've got another UPS which has got a failing battery. I've got to do a modification to this because it's driving me nuts. So let's power this up. And this was taken off power just now. Alright, you can see the battery is already like empty, just powering itself. This was unplugged from power 10 minutes ago. Batteries had it. These batteries don't seem to last very long. These little SLA batteries like this. These ones I've replaced previously from another unit. I've kept them around, thought they might be handy for something, although I haven't charged them for a while, so this one's pretty flat. I've got another one over here which is on charge right now. My intention is to actually forget about the SLA batteries, run a couple of wires out the case, put some crocodile clips on it and stick onto a car battery. Because car batteries last for years, it's got very little loading on it, it'll just sit there, whereas these SLA batteries are just sitting there and yet they die in a year. So I'm kind of had enough of them. And they're expensive, like $60 each or something for these batteries, or maybe $50, something like that. But that's half the price of a car battery. You might as well get a car battery and not have to worry about it for several years. You know, it's ridiculous. These are overpriced and they're not reliable enough. Part of the problem may be where these are coming from. I mean, you may be able to get better quality ones which last a few years like they're supposed to, but trying to get decent quality ones seems to be a bit hard. I've tried different sources and each one I've had has always lasted about a year. So, yeah. If you know a good source in New Zealand where you can get these batteries for a reasonable price which lasts several years, let me know. Anyway, let's pull this thing apart. So it's got one screw here. Now, there's a good chance this battery has actually exploded. They often do that. They'll split down the side and leak the electrolyte out. Well, that's like a gel, but there's still is the fluid in it. Based on how rusty that screw is, that's possible. Excuse the cat, that's a very needy one. It's not even ours. It belongs to a stepson and he's left it here. As he does. Anyway. Right, screws out, you can see it's a bit rusty. Now this one may have been in the flood as well, I can't remember. But the rustiness makes me wonder a little bit. Yeah, can I get it open? It's kind of stuck too. Here we go. It's just rusty in the bottom. So this is probably one which is in the flood. It's got rust along the bottom here. There's no sign of a break on the cell. Usually I split down the sides, but I haven't got it out yet. You may find there is something. So this has got a little nut down there to loosen off. Okay, so there's a little nut there you've got to turn to loosen that jacking screw out. And there's also some nuts inside here which I also have to undo, and I'm going to take that bracket out and I'm going to slide the battery back and get it out. But the first thing I'm going to do before I start poking around too much is disconnect these battery terminals here and get the thing so it's not going to accidentally power up on me. So I've got my tools ready here. I've got a nut driver to get those nuts out. I've got long nose pliers to get into that one on the side. Then what I'm going to do is give myself a bit of a helping hand here. I'm going to stick some oil on these just to help them to come off. The one of the annoying things about this particular UPS is that it doesn't automatically repower itself. So if the power goes off and it goes flat, when the power comes back on again, it doesn't automatically turn back on, which is a bit of a shame because I've got other ones which do that, which power back up again automatically when the power comes back on. This one doesn't do it. I really would like to find a way of doing that. Maybe there's a way of modifying it one day. I'm not going to do it now, but it's something I'm considering because it's just a pain for pain. Well, I'm going to get quite a few power cuts. Anyway, I've taken these battery terminals off already. So now let's get these nuts out of here. So, nut driver. Anything about having these nut drivers? I featured these previously in a mailbag. I've had these for a while now. And if you're interested in these, let me know. Chuck a comment down below and I'll chuck a link up for it. I'll put a link down below in my description there of a lot of my equipment I have now. I didn't used to have that. I'll put it there because people might find it useful. And some of them have got purchase links or review videos, that sort of stuff. You should go and check those out. But if you want physical tools like this, let me know too. I'll chuck some in or something. I haven't got any physical tools, I've only got like test equipment. So I'm sure people want to have physical tools as well. See how there? So that bracket should now come out. I remember this being a bit awkward last time I changed this battery. I think I'll have to pop this battery terminal here out, or that terminal out. Or do I just lift the board out? I think I might lift the board actually. Yeah, let's take the board out. Okay, but it was now. I've taken a bits and pieces off this to try and give myself some room. You also have to take off the bolts on the transformer on this one and slide the transformer back. That should then give me enough room to get this out. Here we go. It's looking promising. Yeah, design of this thing could be better. Anyway, right, back it out now and get the battery out. Hopefully. Right, battery out, and surprisingly it isn't correct. Right. Anyway, like I said, my plan is to put big long wires on these, extend these cables and put an external battery on it instead of having these little SLA batteries which don't seem to last. So I'm going to put it back together. This is that back together. Now let's have a look at this battery and see what we're actually getting on this thing. Picked this up a while ago. It's like a battery ESR tester and it's quite a handy little thing. Good for testing these. You plug that into there, which will stick the leads on. Yes, you can see it does a 4-wire measurement. Turn on. So I was saying 13 volts right now because it's just come off charge, it hasn't got any decent capacity. And 1.157 ohms it's coming up as. That's pretty high resistance. Now these other batteries I've got over here which I pulled out of another UPS, one of those is 50 milliohms, the other one's 102 milliohms. So yeah, those were definitely doing a lot better. Not wonderful. And I also have this battery tester here, 5 amp load tester. So this has got like an indication here for 15 seconds, so you're supposed to hold it down 15 seconds. And that will go off. And it will tell you what the load voltage is at that point, so you can test it. Now a good battery is much higher. So there we go, gone off. So lowest voltage was 7.9 volts. Pretty bad. Now a decent battery will go down to about 11.9 volts, a brand new one. So that's quite a significant difference. Okay, to give you an idea, this battery here was basically flat. This was only 8 volts when I started charging. It's been on charge for about, I don't know, 20 minutes now. And this is also one which I pulled out of a bad UPS, so this battery is not wonderful either. So this has been on charge for a little while, not fully charged. That one's supposed to be because it just came out of the unit. And you can see we're getting 12.5 volts already. I'll hold that down, see how low it drops down to. Okay, and the last voltage is 9.5. So even though this is also a bad battery and it was flat, it's performing better than one I just pulled out. So it gives you an idea of how bad that battery actually is. Okay, so out of curiosity, what I'm going to do is check what the charging voltage is. Now this does actually have a marking on the board just over here. Change char volt. There's a resistor strapped across there, so I think this actually allows you to change your charging voltage. Now I just want to see what it's actually set to currently, because obviously if I'm going to go to a lead acid battery instead of these SLAs, I may need to re-look at what it's doing as far as charging capacity, because it might boil the battery, right? So I need to make sure it's not doing too much. So I just want to see what's actually coming out. So I've got power plugged in, I've just got to turn the thing on. Right, so it's trying to pull up gently, so it's not pulling up hard, so it's very much a trickle voltage. I might just see what it stabilises to, but it's only just gently pulling it up, so it's not a high current trickle charge either. It's quite a low current. I could actually check that, I think. I'll have to look at that. Okay, let's check the current on this thing. So I've got the battery disconnected right now, so I'm going to zero the meter. I've got it set at 2 amps scale. Plug that in. So there's nothing being drawn at all until I power it up. Okay, so it's charging about 300 milliamps. So it's not too bad. It's not particularly high, so it should be fine on a big battery. You know, a big car battery should be 200 milliamps is probably nothing for it really. And that also go down as the battery voltage comes up. So you can see it's dropping 320 milliamps now. It was 330 when I started, and that voltage is creeping up. So I want it to sort of float around sort of 13.1 around there, hopefully, but we'll see. I might have to change that resistor value over there and see what that does. And by disconnecting the battery, we're getting 13.7 volts. That's what its charging voltage is set to. So I might have to look at maybe dropping that down very slightly. Okay, so I've got my little resistance substitution box here. Sounds a big Clyde's one. I guess they both got on Maplins at the time, something. So say floating is 13.7. I'll be playing around with values on here. So it's already got resistor strapped across it, so I might have to look at changing the resistor completely, or I've got a strap on across as well, I'm not sure. So if I tap across there like that, it goes down to 13.3 volts at 82k. If I go to 68k, let's try that one. .3 as well, because that's not making great connection. It's not a very good resistor. Let's go 56k. Oh, 56, get it right. Yeah, 13.1. That's probably where I'm going to target going. So that's 13.1 there, 56k across there. So I'll stick the battery back on, and we'll see what the charge current goes down to at that current voltage with that setting. So 160 milliamps at 12.7 volts. That's not a very high charging current, but it doesn't actually matter if it takes a week to recharge a battery after a big outage, because we tend to get short outages. It might last 20 seconds sort of thing, and it'll come back. And you might get 2 or 3 of those in a day, maybe once every couple of weeks, unless there's big storms and stuff like that. But if you get an outage, it could last an hour or 2. So we need it to last long enough to cover that outage, which is why I want to put a big battery in it as well. But also, it doesn't need to recharge quickly. So if I drop that voltage down enough to get it just above where it should be 100% charge, it will just trickle in a little bit and not put too much stress on the battery, and just hopefully keep it in full condition without putting excessive stress on it by having a high charge current and a higher voltage than it should be. So I might just go and research that. I'm pretty sure 30.1 volts is where I want to go, but I'm sort of thinking about that. I mean, there's little gel cells. Gel cells tend to run at higher voltage anyway, and there's a 13.5 to 13.8, okay, or for standby use. Okay, so it's sitting towards the high end of the standby use. Maybe that's part of the problem why these things don't tend to last. Maybe the voltage is a bit high for them, maybe. Sometimes you can't actually see how to change that voltage. This one's actually marked, which is brilliant. But normally you've got absolutely no idea where you would change that setting on the board. Sometimes there's an adjustment, but very rarely. Yeah, I'm going to research this and just double check that 30.1 volts, which is my current target, is a suitable voltage for a lead acid battery. I think it will be okay, but I was going to check before I commit myself to that. Okay, I've done some research on this. I've decided that maybe 13.1 volts is probably a bit low. I did see mentions of 13.2 being like a long-term maintenance charge, and typically 13.5 is mentioned a lot. So I'm thinking I'm going to go probably about 13.4, because say it's just sitting here all the time. You have to make sure you don't do sulfation and sort of stuff. You get sort of sulfation in the battery, and you need a high enough voltage to break that down and that sort of stuff. So you've got to be sort of up there, but then you mustn't overgas the battery as well by having too high voltage for too long. So it's a bit of a trade-off about what's going to work. And because there's just a constant voltage output from this thing, it's a bit hard to actually know which one to go for. If it's a proper charge controller, you could then do high current, high voltage initially, and then drop it down, and all sorts of stuff like you can do in solar systems. So let's just unplug this so I can see what the float voltage is. 13.7. I was going to say going to go higher, wasn't I? So what do I get from? Let's do 100k. See what we get from 100k across here. 13.4. Okay, I think I might go for that. So I'll definitely want to drop it down slightly from this voltage. So I think I'm going to go for 13.4. So it's 100k across the existing resistor. I think I can go for that. There we go. Right. Have the battery hooked up, buzzer will turn on. Okay, now flow voltage 13.4, bang on, perfect. So that's what I'm going to go for. And the current charging is 130 milliamps at 12.7 volts. So that's at least going to give a reasonable trickle charge. I think I'll be happy with that. That's the modification for that part done. Now I just need to power it all down again and run some bigger wires to these. I'm probably going to use some spade terminals into these, some male ones, and then hook these crocodile clips on the end and just run the wires out of the case. That's the plan. Alright, let's get this stripped. I've got one off already. Do the other one. Come on. This is some wire I've had laying around for a little while, but I've used it for other stuff. It's heavy enough, it should be good enough for this. Now, that terminal's actually a bit big for this. Actually, I might go to a smaller terminal. Now, let's give this crimper a go. See how it's going to behave today. Oh, I don't have the right crimper. Not quite sure what's happened to that. Oh well, let's just give it a go with this thing. See if this will do it. It may or may not cooperate. You can't see what I'm doing, can you? Well, probably what I'll end up doing as well, I think, is because so it's quite high current. So what I'm probably going to end up doing is soldering it as well. I don't particularly trust it. I mean, it's on, but I think I might solder it too. So I did the same the other one. Getting decent crimpers and the suitable crimper for the job you're doing, it's always, I don't know, it can be a bit of a pain sometimes. Anyway, I'm sure there's going to be someone going, "No, you're using a completely wrong crimper." It's like, well, yeah, probably. If it works, you know. Or I'm using it backwards or something. Well, I'm not trained in this stuff. Anyway, it's crimped, right? What do you think of that? Do you think that's going to be a good enough crimp? Do you think it's good enough? I mean, this out one, that's not great either, is it? Right, so the next thing I'll do is heat shrink these things. So I was going to slide some heat shrink over. Should be big enough. Yes, it is. Do both. Plug them in and heat shrink them in place. Obviously I don't want them to short inside the casing anywhere because that'd be quite bad. Yeah. And will it go over the other boot as well? Oh, it's not going to, is it? Oh, denied. Damn it. Okay, I'll slid these boots down a little bit and I'll slid them onto the fitting so it's completely covering the whole thing. And I'll slide the boots back down again afterwards because they're quite stretchy, so I should be able to do it. Let's get hot air. Shrink this down. Should do it. Slide the boots over. There we go, that's worked. Excellent. Exactly what I was planning. Okay, cool. So what I've got to do now is this end, which I've got to take this whole fitting off and attach these. Alright, so I've taken the little sleeves off these, I've already put them onto the wires. Always going to put the sleeves onto the wires before you do crimping. Alright, oh, I've got to strip this back. Where's my stripper gone? I think I'll put it away. Hold on. Okay, strip this back. Get the correct one. Now, so this is crimpable as well, so I'm going to crimp it in. And I will probably solder it too, just like I did the other end. Alright, so let's crimp the wire on. Which end do I think I need? Let's go for that one, shall we? No, next one over. No, it's crimped. I don't know about how well it's crimped, but it's crimped. Let's do this one too. Like I said, I'm going to solder it anyway. Okay, it's that one. I'll crimp all up, then I'll solder them both together at the same time. I've got the iron in my hand. Okay, I'll strip this one off. No, I doubt there's going to be someone that is going, "Oh, you're doing this completely wrong." Well, that may be the case, but, you know, I don't know. I'll just do what works for me. You know, it's probably a completely wrong crimper, but hey, it holds. Okay, let's solder these up. I always like to solder things if I can, just generally better. Okay, so next thing I'll do is get the casing modified so I can get the wires out of it. Okay, so see here, I've already started nibbling away, got a nibbling tool here, just stick it in there and just squeeze and cut it out. Very handy little tool, great for doing project boxes and stuff like that. And in this case I'm going to use it to get the wires out of this casing. So at least that's the plan. Slightly more wider. Also, you have to be careful about sharp edges because you don't want to have an edge that cuts into the cables because that would be bad. What I'm trying to do here is to get that to fit nicely. Now you can see on here, maybe you can see it, if I get it in the shot you can see it. This side chassis here, it cuts in. Right, so there's actually a bit of a gap there. So what I'm trying to do is get a gap through the casing here at the same point. So hopefully I can then just shove that over and have it all line up. So let's just have a look, see if I've got achieved that or not. Although somehow I've got the thing stuck on the case. So yes, what I'm trying to go for here is to get it through here. Right. So I bet the chassis in here a little bit more, just to get it a bit further away. I think I have to bring this slot here up the side a bit, because I think it's just a bit too pinched right in that point there. I don't know if they're cutting into the wires, and of course also I bring the wires around. So if I cut this into that, it will be a bit easier for it. I don't really want to cut the side, but okay, so that's through there. It's got a bit of slack in there, so it's not actually tight. I think I might go a little bit further just to give it slightly more play. I don't want it getting caught around too tightly because it will eventually cut into it, so I need to be careful of that. I'm also going to try and round off that edge as well with a file just to round it so it's not going to cut in. Quite important. Okay, so there you go, it's done. So I've cut this up a bit further, rounded those edges off a bit so there's no sharp edges. I'm going to finger around it without feeling sharp, so that feels good. The wires are not pinched, so they're a bit loose there. So I'll just fold out like that, nice and easy, no stress on the cables, so it'll just sit there quite nicely. And clip those onto the battery outside. I've already put the screws back in again. You may notice I've got a crack in the front panel here. I probably do need to do something about gluing that back together. This keeps flapping around, it's getting bigger and bigger, so I need to sort of stick some glue on that too. I'll do that before I put it back in the service. So make sure you subscribe, click the bell icon, that sort of stuff. And I've done a few videos on these. Check out the other videos I've done them as well. I've done, I think, 3 or 4 UPS conversions, modifications, this kind of thing. So go and check those out if it interests you. Catch you later.